Hello, everyone. Welcome back to another edition of A View from Earth, the official podcast of Fiske Planetarium at the University of Colorado in Boulder. Hope everybody's still doing well and staying safe. We are happy to be here with you. My name is Tara. I am a planetary scientist and a CU alum. I'm also a presenter at Fiske and outreach coordinator and all sorts of other fun stuff, including co-host of this podcast with my friend Colin. Hi, Colin.
Hey, Tara. And also to our listeners, hello. That was so weird. My name is Colin Sinclair. I am an undergrad at CU. I study astrophysics. I present at Fiske. And of course, here I am speaking on this podcast, which is what I do as well. Back to you, Tara.
I'm going to force interview our producer, John. Say hi,
Hello.
John.
How's everybody doing?
John loves being on camera.
Yeah.
Yay!
Yay. So today we are talking with Dr. Larry Esposito, who is a specialist in a lot of things, but today we're specifically talking about Venus. He's been pushing for a Venus mission for years and years. He's also worked with the US and Russian space agencies on missions and concepts going to Venus. So he's going to tell us a lot about that, including the newest discovery of phosphine in the atmosphere of Venus, which is the super hot button topic about Venus right now. But even before that, NASA was really looking at putting spacecraft back in and around Venus. There's a couple of mission proposals that have come out. Maybe you have seen, if you're extra super savvy, these discovery missions that have been proposed. So we're all super excited about that and really excited to talk about Venus because it doesn't get nearly enough love, I don't think. I don't think people pay as much attention to Venus as it deserves.
So I am very much not one of these extra super savvy people that knows what's going on in the spaceflight community. Where could I and anybody else find these updates? Like if I wanted to know what are the current proposals or plans, where, like, is there one spot that has all of that information?
Yes, it is this amazing thing called the internet.
Okay, Tara. I mean, on
no,
the
seriously
internet.
though, like literally. So, so generally when these kind of things happen, we'll get a little bit into the details here. So NASA selects missions and there's different categories of missions. So there's one called Discovery, there's one called New Horizons, there's another one that I forget, and then there's the flagship missions, which are the big honking things. So I think it was just last year that they announced the Discovery class missions, which are kind of like a low, moderate cost. They're not the lowest category, I don't think, but they're like in the middle. So like a moderate cost mission. They announced 4 of them. So this is it's all publicly available knowledge. So you can literally just Google NASA Discovery missions and it will take you to either probably the NASA homepage or even just Wikipedia. Generally has that, and it gives you the mission descriptions and things like that.
Oh, so, so I just Googled it, NASA Discovery missions. And you know how Google will sometimes like put together a little like thing for you that is just, and they've done that for the Discovery missions. So it's showing all of these different things. I remember actually Wikipedia being really useful because back in February, in the before times, actually that was like the just before times, that was when Rami and I were doing the A Closer Look show. And a lot of that was like, putting together like the history of the space flight. And the most useful resource was Wikipedia, because that was the only place we could find like dated itemized lists of missions. And I remember being very frustrated with the NASA website because every mission page exists, but they're not all in one spot. Like you have to like find them, and it's I guess if you enjoy like puzzles and searching for things, then that would be fun. But I was like, I just want to look at them and see where see them all together. So,
well, I think NASA has a specific team of web designers, but Wikipedia has literally thousands of people.
Right.
So
right.
I think if we had the same number of people contributing to the NASA websites, we'd probably get a lot more done.
Yeah, absolutely.
But
well,
it's more like 4 dudes. Don't give them a hard time.
Yeah. No. I think, there's also different goals, you know, I mean, Wikipedia has a very specific formatting guidelines to say, hey, if you're going to do a list, here's how it has to look, you know, so it's super consistent. And, you know, because I use Wikipedia for things other than looking at NASA mission lists, then I already know kind of what to expect. Whereas I don't spend a crazy amount of time on the NASA website. So I'm not acclimated to its layout and how it works yet. So props to anyone who is, I suppose.
Yeah, so of the 4 Discovery missions, there's 2 that were proposed to go to Venus, and they haven't made the selections yet. Those should be coming soon-ish, I think. I'm not positive. There's also one going to Triton, which I'm way excited about, but we'll see what happens. I will be happy with any of their selections. It seems like it's a really cool list. There's 2 to Venus, 1 to Triton, one of the moons of Neptune, and 1 to Io at Jupiter. And I'm cool with any of those. TBH.
Let's see. They have really cool names. The one going to Triton is called Trident, like the gum. That's crazy. Or, you know, like the weapon.
It's Neptune, the
Not
god
the
of
weapon.
the sea.
What is that? The pitchfork. What do you call that? What's the name? The class.
It's called the Trident.
No, well, I know.
I mean, that is the name of it.
The utensil.
Because that's what it's. Yeah, I guess.
Like what
That's what Neptune
Trident?
carries.
Listen, John.
John's dying over here.
For any audio only folks, John is just on the other screen cracking up, muted. It's fine. But then there's also, you've got Da Vinci Plus, which is one of the 2 Venus missions. That's a cool name. Which, by the way, is an acronym for...
Of course it is.
Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging Plus.
Plus. We love our acronyms, man.
Always.
We gotta have an acronym.
Always. And then we have, I don't know if I'm going to say this right, Veritas, or
Veritas.
is it Os or
Veritas.
Veritas, okay.
Veritas. It's Latin,
Venus
I think.
Emissivity, Radioscience, INSAR, Topography, and Spectroscopy. Did they just use an acronym within an acronym? Did NASA really just do that?
If anyone's going to do it, it's going to be NASA.
Wow. And then there... And then the Io mission is called Io Volcano Observer. That's its name.
Or Ivo.
I mean,
You'll notice they're in quotes, they're in parentheses at the end. It's always IVO.
They are. That's true. That's funny.
I don't know. We love our acronyms, man.
Yeah, very cool. Yeah, so there's a lot to unpack. Well, this was actually really easy to find. NASA selects 4 possible missions to study the secrets of the solar system. And you can read about all of these here. So
yeah. So those are always exciting.
And this is, sorry, you may have said this already, Tara. When should we expect the decision on these?
That I don't know off the top of my head.
Okay.
They were announced back at the beginning, like the end of last year, I think. And then I think they narrow it down to 2. And then I think they do the final decision after that.
So it says, there's this editor's note that says this release was updated on June 19th, 2020 to ensure consistency when referring to each of the proposed missions. Final selections will be made next year. So it sounds like we should expect, assuming next year is, you know, a year from that update, I suppose we can expect next summer.
Next summer.
So, and this, I mean, that update was made obviously in the middle of the pandemic. So this is still, it sounds like that's still the roadmap, even given, you know, changed circumstances.
Yeah. They seem to be trying really hard to keep things on track, despite all of this.
Mm-hmm.
You know?
Yeah.
Yeah.
Cool. Well, should we go ahead and move forward with our interview with Dr. Larry Esposito?
Let's do it.
Awesome. Cue music. All right, so now we're talking to Dr. Larry Esposito, who has been a professor of planetary science at CU Boulder since 1977. He was highly involved with the Cassini mission to Saturn, as well as the earlier Voyager and Pioneer missions. He even discovered a new ring around Saturn. Dr. Esposito has been a participant in numerous US, Russian, and European space missions and used the Hubble Space Telescope for its first observation of the planet Venus. Dr. Larry Esposito, thanks so much for talking with us this morning.
Good day.
So I guess the first question to kind of start the ball rolling that is you have a long time been a proponent of a mission to Venus. What is it about the planet Venus that interests you, or why do you think it's an important place for us to understand?
Venus is a planet. It's the brightest planet. It's captivated humans for decades, centuries. The Aztecs followed the motions of Venus. It's an object in the sky. It's one of the most reported unidentified flying objects. It's something that captures our attention, named after the goddess of love. And from our first observations of it in the space age, it was clear it was completely covered with clouds. So it's been a mystery until we were able to penetrate those clouds with radar and with missions that have landed on the surface. And instead of resolving the mysteries of Venus, was it a tropical paradise? Is it really more like hell, full of sulfur and sulfurous gases, poisonous gases, high pressure and temperature? And all that basic curiosity is the first thing. But secondly, Venus has many parallels to our Earth. It has the worst case of global warming in our solar system. It's a place where the greenhouse effect, which keeps our planet warm, has run amok, and that's something that could potentially still happen on the Earth, even through human interference through production of greenhouse gases. So Venus is a mystery. It's right up there in the sky. We see it in the morning and the evening. It tells us something about the Earth, but other terrestrial planets too, like Mars. How is Venus different from Mars? And particularly, how did Venus go so bad? How did it end up so terrible? If it's a twin of the Earth, and some people argue that it's a sister planet, it's an evil twin. And when we look out at Mars and at planets around other stars, we can ask ourselves this question: are those planets like Earth that we find, or are they more like Venus? Or if they're like Venus now, would they be like Earth in the future, or vice versa? So these ideas, the apparent brightness, the visibility and motions of Venus in the sky, its mysteries and comparison to the Earth and other terrestrial planets in our universe.
So it sounds like Venus has a lot of both just curiosity around it, but also can teach us a lot about what's going on here on Earth and elsewhere in the solar system and in the universe. So it's kind of this overall like fantastic object to learn about.
Yes, but at the same time, it's more difficult to explore Venus. And that's one of the explanations why other planets in our solar system, particularly Mars, have been the focus of more attention. And on top of that, the mysteries are at least harder to crack, many of them on Venus, so that it's been a better return. NASA has decided in the past to spend more of its resources on going to Mars and fewer of those on going to Venus.
And you mentioned that Venus is a lot harder for us to explore. It seems like it's kind of a nasty place to go. Can you tell us a little bit more about, what it is that's kept us from really exploring Venus?
Yes. So first, it's completely enshrouded in clouds, so we can't really see what's underneath the clouds. Secondly, it's truly a hellish environment. The temperature on the surface is similar to the temperature in an autoclave, about 450 degrees Celsius. The pressure there is 100 times the pressure on the Earth, like going meters, hundreds of meters deep into the ocean. And it's full of unbreathable gases, no oxygen to speak of, but mostly carbon dioxide and poisonous gases of sulfur. Sulfuric acid is the dominant constituent of the Venus clouds. So altogether, a very inhospitable place. And the longest that any spacecraft has survived on the surface is just an hour. So all these things together, going to Venus, to a somewhat unknown location, descending through the clouds full of sulfuric acid with a temperature and pressure gradually increasing that would crush many vehicles, and then arriving on the surface where the temperature gradually heats up to the point that metals will melt and all the electronic circuits fail.
So, oh, sorry, Tara, go ahead.
No, go ahead.
Thank you. I was just going to ask, so obviously this has proven to be a very difficult place to put even, robotic vehicles, right? It's clearly dangerous for living things like people. But, in the past, obviously NASA and other space agencies, we can use robots to do a lot of our work because robots are a lot less, I guess I should say they're a lot tougher than humans are. Is there no technology today that is readily available and ready to go that would overcome these, super high temperatures and pressures? Is even our normal technology still going to fail in the atmosphere and environment of Venus?
So one of the strategies of past proposals is to bring a little bit of the Earth to Venus, to have a pressure vessel like a deep sea diving bell, and inside of that to have the experiments that operate essentially at Earth temperature and pressure. And the problem with that is it doesn't take very long for the heat from the atmosphere to be conducted into the inside. So the first answer is we could do this if we had a really good refrigerator. So if we brought a piece of the Earth to Venus under pressure protection and ran a refrigerator, air conditioner sort of thing. And I've been approached by this by Sandia National Labs, who were thinking there's so much power required that you'd probably need a nuclear reactor to do this. And so this is a possibility to bring a little bit of Earth there and expend enough electricity, perhaps created by nuclear power, to keep it cool for days or maybe weeks. Unfortunately, the price tag is very high on that. The second thing is to have a more placid approach is simply to take a lot of insulation to Venus. And the early Russian missions, which in the early days of the space age, we complained about the Russians as having really big, clunky missions and using old technology like valves and pipes instead of semiconductors and transistors. But in the Venus environment, this is actually an advantage. It takes more time to heat that up. And so the longest surviving missions on the surface of Venus have all come from the Soviet Union and now Russia. And another possibility is along those lines of just trying to survive as long as possible. You can bring various sorts of compounds that are frozen and change phase, so like packing the spacecraft in ice. So even the Russians did that. Actually, they, in the cold of space on the way to Venus, they had water that froze, and then when they entered the atmosphere, their spacecraft was full of ice, which took a long time to melt. And there are better compounds that are available for that today. And so if you do all of the measures that are inactive, you can probably survive on the surface of Venus for maybe 5 or 6 hours. But coming back to your question, is there any technology that we have that can work on Venus? The answer is no. The Glenn Research Center is developing computers, memories, radio transmitters that could work at those temperatures, batteries, and still it's all experimental, nothing proven yet. But there could potentially in the next few years be a small lander that could last for some months on Venus that would have very limited capabilities, maybe seismometry and weather and the ability to send a bleep to the Earth every time it detects something interesting.
So, when we send a rover to Mars, for example, right, we see these vehicles lasting way longer than they were intended to, and then the returns just keep coming. It sounds like even with this somewhat more revolutionary technology that would enable a spacecraft to exist at all in Venus without completely failing, it sounds like any mission to Venus into its atmosphere would end up in the spacecraft failing. So is that true that
yes,
that's
that is true, that you can't survive on the surface, and the only question is how long can you survive?
Wow, that's so
But there are
upsetting.
places in the atmosphere where you can survive. So for example, at balloon altitudes at about 50 kilometers or 30 miles above the surface, the temperature and pressure are very similar to what we have here on Earth. So if you were to float a balloon on Venus, and the Russians have also done this, although the US has never had a balloon on Venus, the balloon could last for days or weeks or even months.
What about moving like from that top layer down in deep, closer to the surface quickly, and then you come back up before stuff goes wrong? Or is that also still going to cause all sorts of problems?
So that's still possible, but expensive. And not just in terms of money and designing the technical aspects, but it's expensive in that it weighs more, and then it takes a bigger rocket to go to Venus and a bigger rocket to enter orbit. And there's a recent concept study for NASA of a flagship, a big mission to Venus that involves a balloon that has variable altitude capability. But it only goes from like 50 kilometers, which I talked about before, up to maybe 60 kilometers. So it goes up about 10 kilometers and comes down. It can't easily go down into the surface because then you encounter those extreme conditions again, which very much shorten the life or destroy the capability of the balloon.
And I know we've thought about that not just for spacecraft, but as far as things that might live on Venus. They always talk about things not necessarily down at the surface, but maybe up in those like high cloud layers where it's a bit less frightening.
So on the Earth, the history of life is life arose in the oceans and then colonized the land. On Venus, there's a similar possibility, a speculation that billions of years ago, Venus was much more like the Earth when the sun was not as bright as it is now, and that life could have originated on Venus, or life from the Earth could have been transported to Venus by impacts hitting the Earth, meteorites that knocked off pieces of the Earth, and the microbes could have infected Venus, or perhaps vice versa. But anyway, 4 billion years ago, potentially there was life on the surface of Venus, oceans, and much more like the science fiction idea of a swampy tropical paradise. And then as Venus became warmer, as the greenhouse effect increased, and before the oceans boiled away, that this life evolved from the oceans on Venus to the clouds of Venus, where it might persist till today. And in fact, this has been a popular speculation for some decades now, and even some of the features in Venus, the cloud markings we can see at the tops of the clouds, some of those have been possibly identified with organisms that use the dark absorber as a sort of sunscreen. So potentially we're even seeing colonies of life that are causing some of the visible markings in the clouds of Venus. That's a very extreme speculation, but nonetheless, people have proposed, they're very interested in the possibility of life on Venus, and have proposed ways that the Venus organisms could be encapsulated, protected from the ultraviolet radiation from the sun and the sulfuric acid in the clouds, to have a sort of lifestyle and a life cycle.
So just about a month ago, maybe it's a little bit less than that, there is this very interesting discovery or announcement of a discovery of this thing called phosphine in the clouds of Venus. Larry, my question for you is, and you knew this was coming, is there life on Venus?
Well, that's a great question. I'd like to know the answer to that question. And the report of phosphine, the detection of phosphine in the Venus clouds is, an indication. Phosphine is a bioindicator. It's a signature of life on the Earth. And the amount that's seen on Venus is very hard to produce by any non-biological means. So definitely, I'm very interested in this. But the question is, I have the same question you just asked. How can we confirm this? And if there is life on Venus, what is it like? So this involves just 2 steps. The first step is determining if the detection is correct. And if so, mapping out the phosphine, the indicator of life on Venus. So similarly, we can map out methane or carbon monoxide on the Earth, which are related to living activities. And so in that way, we could confirm this measurement. And then the second question is, if there really is phosphine on Venus, if that detection can be confirmed and we can map out how it varies with place to place, time to time, day to night, that sort of thing, then is it coming from a biological source? And that's a tougher question because, for example, methane, which is similar to phosphine, methane is a carbon atom with 4 hydrogen atoms. Phosphine is a phosphorus atom with 3 hydrogen atoms. So methane has been discovered on Mars, which is also biologically created on the Earth by microorganisms. But many of the explanations, maybe the best ones for the existence and variability of methane that we see on Mars, is that it comes from non-biological sources. So to answer that question, we need more information to confirm the existence of phosphine, which is a real detection. They really saw something, but is it really phosphine? And secondly, to connect that with the ecosystem and the biological processes that produce it on Venus.
This might be a somewhat technical question, but I am not informed. What was the detection? Like, what's the background of this announcement that we found phosphine? Because, obviously we're talking about confirming, the phosphine that was reported. What do we know now? How did they, determine what they've published so far?
So the investigators who wrote the paper first saw an unknown absorption with an infrared telescope that's in Hawaii. And then they followed that up with another telescope in Chile. And the two of them both saw the same fingerprint of light absorption from the Venus clouds. And then they went to the book of fingerprints. There's a data set that a library of all the transmissions and fingerprints of all the common molecules. And they went, and the only thing they could find that would fit that absorption that they saw, the radiation from Venus that's hot underneath the clouds is being absorbed by chemicals in the clouds, and that makes a little wiggle in the spectrum that's seen by these telescopes. And the only wiggle that corresponds to that is phosphine. And so that is the detection. They tried lots of other explanations, different gases and different production mechanisms, but all of them, they concluded, were too inadequate, were not adequate to explain the signal they saw. And I would have to say that in the email and in the news and in discussions I'm having with my colleagues, all of those aspects are being challenged. So some people believe the arguments in the paper. Other people are contesting whether the detection is real, whether it's really phosphine, whether it couldn't be produced by non-biological processes, and if there is some sort of life that could possibly have a life cycle in the clouds that would explain the existence, the persistence of life after it evolved from the surface of Venus, and the production of phosphine as one of the byproducts of that life.
Well, I think that's one of the beauties of science, right? Is that you have to be unequivocally correct in order for it to be widely accepted. If there's any doubt, that is reasonable that, you can be proven to be wrong, then it doesn't get accepted. And so, I think that's a cool thing, because then at the other end of the tunnel, if we come out and the scientific community has consensus that yes, this has some really cool implications, and we've now been able to really wash out all of these ideas, it carries a lot more power with it that way, because now you have everyone agreeing, yeah, we tried to prove this wrong, but we couldn't. And so
I agree completely. That is the scientific process. There's now a hypothesis that is consistent with some of the data, some of the observations we have of Venus, 2 separate observations, and other scientists are checking every aspect of that, from the initial detection to every possible explanation. And papers are starting to appear which could explain or discredit this measurement. And it's premature to actually say, whether it is proven or it will be discredited or it will be proven at this time.
I also like how it seems to be bringing together a lot of different sort of specialists from different fields. We have chemistry and atmospheric science and astrobiology, and everybody kind of gets to get together to work on this problem, which I think is kind of fun.
Well, that gets back to the original question, which is how could we solve these complicated problems? And we could if we had sent more missions to Venus, or now if we send a new mission to Venus that either looks at the big picture, the way that we've been looking at Mars and other planets, or like some of the more focused missions, looks at the big picture with a special emphasis on searching for life in the clouds. There also are some people who say, wait, of course you scientists are interested in Venus, but the real question is biology. Let's go to Venus and bring back or have a microscopic observation of a Venus organism, and then later on figure out how that all fits together in the history of Venus and the climate of Venus and the future of the Earth and comparison to exoplanets.
Which kind of brings me to my next question. Do you think this new discovery will kind of affect the kind of missions that NASA might be selecting in the coming years, like maybe in balloon versus an orbiter, or even like a sample return mission or something like that?
Yes, this will affect NASA's behavior, and this will affect the advice that scientists give to NASA. And NASA is currently considering two concept studies that are under development for Venus missions. One, a radar orbiter, and the other, a descender to the surface of Venus, which takes pictures on descent and also makes measurements of the clouds. And I've been in contact, not with the people on those missions, because there are competitors here at the university. We proposed a slightly different mission a year ago, and that hasn't been selected for further study. But any of those missions, if NASA flew them, would tell us something about this problem, could confirm or measure phosphine and place it in a context where we could tell whether it comes from a biological process, from organisms, or something more geophysical. And I would say if NASA selects either of those missions under study, it would probably supplement them with experiments that might be more useful to answer this particular question. And now NASA is entering a study through the National Academies of Sciences for advice what to do in the next 10 years, the so-called decadal survey, which is a survey of NASA advice that extends for 10 years. And the members of that group are keenly aware of this discovery and are going to be making advice which is clearly impacted. It's too soon to say whether that would call for particular missions or something like that. But the advisory groups to NASA who are preparing the next 10 years of strategy for NASA missions are aware of this. And beyond that, the Indian Space Agency is planning to send a mission to Venus, which is not completely designed yet. And the Japanese have a mission that's in orbit around Venus. And my particular view is that style of mission would be very good to follow up on the discovery that was made of phosphine. So potentially the Japanese would talk about expanding the style of mission that they have in orbit now and sending a new mission. At the same time, there's a joint mission being designed by the US and Russia to land on the surface of Venus. And as we said earlier, it's only the Russians who have successfully landed on the surface of Venus. It's, in some sense, their planet. And this ongoing study could also be updated to include checking up on this particular life issue, making that a bigger part of the proposed mission. And there's the possibility that later in the decade, the Russian Space Agency, with the cooperation of NASA, could send a mission to Venus. And I haven't mentioned, if you read in the news, there are various private organizations that are considering mounting missions to Venus independent of national programs to address this question.
So, go ahead, Tara.
I was just thinking while we're talking a little bit about mission design, sample return is actually getting to be a really big thing right now. We're sending things to Mars to take samples. We're getting on asteroids and things like that. I'm wondering if it would be feasible to maybe get a Venus atmosphere sample return sort of thing, something that could maybe fly through and scoop up some gas and then bring it back to Earth. Is that feasible, or is that something that we could do?
Yes, that's feasible, and it's been proposed. It's more risky than the missions that we've sent in the past, and potentially more expensive as well. If you're looking to identify life, we can think about the history of Vikings on Mars and the search for habitable regions in the US NASA Mars program right now. And the most definitive determinations of life would involve bringing some of the organisms here or testing out some part of the Martian or Venus environment in an Earth laboratory. So that's a very interesting possibility. And although there aren't any missions currently under study to do that, this concept has been proposed and potentially could be something that one of the national space programs or NASA or the national academies could recommend and carry out in the next decade or so.
So, we were just talking about this potential collaboration between Russia and the U.S. to get some serious work done, in terms of going to Venus. In the past, actually just a few weeks ago, the head of Roscosmos, which is the Russian Space Federation, right, maybe an analog to the U.S.'s NASA, declared that Venus is a Russian planet, right? Meaning that, as we've discussed, they're the only space agency to successfully send spacecraft to the surface of Venus. And it seems like a somewhat bold claim. And I'm wondering how it sits with members of the US Venus community. And if you think that could affect, NASA mission selections in the future conversations about going to Venus. I guess, in other words, I'm asking, could this be the start of another space race like we saw with the moon, but now it's Venus?
A very interesting possibility. But the problems that we see, the difficulties in solving the mysteries of Venus, including phosphine, require many, many observations and of different styles and of different times. And I would say, although a space race is possible, a better outcome would be multiple nations cooperating. For example, a Japanese orbiter and the Russian lander and a NASA gas chromatograph mass spectrometer and a private organization that brings back cells from Venus clouds. So that sort of organized program and the leadership role could be taken by the US in that. And so that would be a little bit different than the space race, different than the Apollo program, where instead of trying to beat the Russians and beat the other nations to answer this question, we provided enough interest and resources so we would be the natural leader of that. Although, as you say, if it involves going to the surface, the absolute leaders in that are the Russians.
Do you see anything particular that would stop us from having this sort of collaboration? I know it does happen in planetary science, but not quite on that level of scale.
So what are the limitations? Of course, national pride and interest. There would be a disagreement about exactly what to do. And so even scientists from the same country can't always agree on which is the best experiment or which is the best mission observing approach. And the key one, though, is money. It's going to cost a significant amount of money, dollars and rubles and yen, to carry out such a collaborative mission. And the excitement of the Venus Joint Science Definition Team for Venera D for the next Russian-US mission is that a report was released on that from that joint group on a joint mission, but there hasn't been any release of funds in any country to actually develop or build the planned mission, the planned approach, which would involve both US and Russian components.
I wonder if, this idea, and I guess this is more just a question for the two of you as planetary scientists, what, how, uh, uh, people, for example, submitting to the decadal survey decide what's important. When there's a discovery like this whole phosphine fiasco, listen to that fake alliteration, and it kind of stirs up the community, both scientifically speaking, but also just the wider public community that sees on the news, ooh, they're saying there might be life on Venus. That's cool. Does that add a lot of priority uh, to designing missions and collaborations to go to Venus, or is that I guess I'm wondering how much weight does that carry in the community? Do people immediately jump on that, or is is it a longer process than just saying, oh, this is really cool, we should figure that out right now?
So I have to make a confession that it's been publicly announced. The Decadal Survey has a steering group, and I'm a member of it. And it also has a panel on Venus, and I'm the vice chair of the panel on Venus. And the first meeting of this group was yesterday. So I have to say that I can't really answer all those questions in detail because that's the subject, first because of confidentiality, and secondly because that is the subject of our work. But on that panel, people are concerned not only about the scientific results, but also the practicality of going to Venus and answering those scientific questions. And because space exploration is so expensive that only countries and only some richer countries can actually do it, we're also concerned about the political aspects. So I think it would be fair to say that the public interest and the general scientific interest are going to play into the considerations of the scientific advice, but the challenge for that group is to make a scientifically based representation and propose a program for the next decade for the NASA Planetary Science Division. So there's definitely interest in this, and the people who are discussing it inside and outside of NASA are paying attention to everything, including public interest. But remember the Viking experience, where there was a lot of public interest in finding life on Mars. And when the Vikings landed on Mars and provided a sort of confusing answer, mostly a negative answer to that, what Carl Sagan optimistically called the fact that Mars is not teeming with life from pole to pole. Well, the fact that the public interest and the hyped up interest in life on Mars and the failure to discover it from the Viking mission led to a setback of some decades in Mars exploration. So I think people are careful both about, the power of public interest, but also the danger of following the public interest and not providing the appropriate scientific return to answer the realistic questions that can be answered by a or family of space missions.
That was a very succinct and politically correct answer. I like it. So aside from just Venus, we'd always like to ask our guests a little bit about their history too. You've obviously had a successful career in planetary science for decades now. Can you tell us a little bit about where you started and kind of how you got to where you are today?
Well, of course, I really love my work, and I'm very fortunate that I'm able to do it. And I've had some really good outcomes, some very positive aspects of my work, which are personally very satisfying. And so I think, a person would have to say, I would have to say about my career, I've been blessed with a lot of good fortune, being in the right place at the right time, or having developed the right computer program, or thought about the right spectrometer that is what NASA could use for any particular time. And I've worked with the Russians and the Europeans and the Japanese also, and pretty fortunate to be involved in these major activities, national activities that are telling us something really important about the universe we live in, and at the same time, there's a role that I've been able to play in those missions. So that, good fortune is at the heart of it. But if you ask my particular history, when I was a kid, I had a telescope. I joined the Boy Scouts of America. I got astronomy merit badge. I worked at a summer camp where I taught astronomy, got scouts up in the middle of the night. I went to the Massachusetts Institute of Technology, and there's just all sorts of things happening there. It was during the Apollo program, and I was really interested in scientific aspects, the universe, and particularly the question of, how does it all fit together? As an undergraduate, I was a mathematics major at MIT, and I really had an interest from my earliest days of looking up into the sky and trying to figure out, well, how do we explain that? What's the idea? What's the equation? What's the reason that things happen there? So people who are interested in careers in astronomy should follow their natural curiosity, should take advantage of what they're interested in, and also whatever personal characteristics that you have that might lead you to be able to make a step in this international exploration of space. And I was very lucky to be hired at the University of Colorado when the university was running missions to Jupiter, Saturn, Uranus, Neptune, and Venus. And I was in a position to assist us here. And then later, our specialty at the university is building experiments for space missions. So I got involved with designing and building, proposing, and then operating space experiments and space missions, including the part of, after we get the observations, after we take a look at the planets, what do they tell us? And trying to explain that to my colleagues and to other members of the public, including I've had good luck writing some books that bring some of this information to the general public.
You scientists always have the best answers to that question. I don't know that we've ever asked someone that question and they didn't say it's always so humble and inspiring. Thank you for having such a great response to that.
Yeah. All true.
No, absolutely. It's, it's just very like, every time we're talking to someone and they say, oh, here's how it happened. It's always just like heartwarming. It's very inspiring. So, well, I guess we can move into a special segment of the podcast that we are encouraging our listeners to take part in. And that is something called Capcom Q&A. And the way this works is anyone can send in a question via email or through our website or what have you to us about really any space topic. And we will then take that question and forward it onto the experts that we're interviewing, such as you. And so we have a couple questions that people asked regarding Venus. And so the first one comes from Terrence in Boulder. And Terrence is asking, despite being further from the sun, why is Venus hotter than Mercury?
So that's a good question. And the temperature of a planet depends on a balance between the energy that's coming in, which is mostly sunlight, and the energy that's radiated, which is heat energy, infrared radiation. And it's the balance between those two that determines the temperature. So if there's more light coming in and less going out, the temperature goes up. It goes up until the amount of outgoing radiation, which depends on the temperature, increases with temperature, exactly balances. And so in the simplest case, the surface of a planet just reflects light from the sun. So the further away you are from the sun, the cooler you are. That's the natural way. But in the case of Venus, its immense atmosphere is like a blanket. And this is how you can be warm at night. On a cold night, you put a blanket over you, and that reduces the rate that your body heat is escaping from you. And so the blanketing of the atmosphere of Venus causes the temperature to rise so that what leaks through the blanket, through the atmosphere of Venus, through the clouds and carbon dioxide in the atmosphere, exactly balances what it receives from the sun, which, for example, the amount of light received from the sun is less for Venus than for the Earth because its clouds are so reflective. So this is a little bit of a complication. If you think about looking for habitable planets in the universe, there's often a simple diagram that says you're so far from the planet, you're so far from your star, you're a habitable planet. We have to add this additional complexity of the blanketing of the atmosphere, which was very bad for Venus. Of course, things went to hell there, but on the Earth, it's important that the blanket of the atmosphere keeps our surface warm enough that liquid doesn't freeze, that the oceans don't freeze over. And we also have to be careful that humans are producing these same greenhouse gases, so they're adding more blankets to the Earth and potentially raising the temperature, probably not enough to get the disastrous effects on Venus, but some very significant effects on Earth if we do the things that raise the temperature there here on our home planet. And as they say on TV, don't try this at home.
So Rachel from Colorado Springs says that she's heard that Venus may have been Earth-like in the past, which we talked about a little bit earlier. But the second part of the question is, how do we know that? Or do we know that, I guess?
So that's a good question. There was nobody here on Earth looking at Venus in those days. There could have been microbes and mats of algae on the Earth, but nobody was taking notes. So you have to go to Venus and find what's in the history that's a marker of those past climates. And there are two good examples. One are gases in the atmosphere, which have been produced during the history of Venus and remain there, particularly the noble gases, which don't engage in any chemical reactions. And so measuring the noble gases on Venus would tell us about the history of the interior of the surface. The second thing is if there were oceans on Venus and lakes and streams, that makes particular sorts of rocks. And if you go out on the Earth, you can find rocks that are made in streams, concretions, and et cetera, and rocks that are made in the ocean, like limestone. And if we went to Venus and were able to measure the type of rocks on the surface, we could see if any of those preserve the record of being formed in a wet environment.
So it sounds like, as always, we need to go to Venus to figure these things out.
Yes, I'm in complete agreement.
So Jessica from Boulder, this is our last question of the day, asks, I saw that they recently detected tectonics on Venus. How does that work if we also think that Venus is, quote, dead inside?
That's a good question. It turns out the answer is Venus is not dead. And this is just one indication. And the tectonics just means motion. So like plate tectonics on the Earth, the continents move and drift. There also have been motions on the surface of Venus, which we can see. And that's been known from the first radar missions that penetrated the clouds to give us our first pictures of Venus' surface, that the surface has been bent and twisted and in some places pulled apart. So this shows that Venus has had tectonics. The new paper says that continues to the present. And so like the phosphine detection, there are people who might contest that and it's not completely proven, but the source of tectonics on the Earth is radioactive heat, which comes from the inside of the Earth. The same process is happening on Venus, and because of that, that heat has to get out somehow. One of the most likely ways is by moving the surface. And so there would be a natural expectation that tectonics continue to today and that Venus is not dead. In fact, there are even some reports of active volcanoes and earthquakes on Venus up to the present moment.
So I'm curious, we know that like here on Earth that liquid molten core that allows us to have those plate tectonics is what helps generate our magnetic field that's so strong and robust. But we don't see that same kind of magnetic field on Venus. If it has this kind of liquid stuff inside, why doesn't it get that dynamo convection, kind of like we have that generates that field?
That's a good question, and I don't know the answer.
Fair enough.
But if I were curious about this, like you, I would send a magnetometer to the surface of Venus and also a seismometer that would measure the motions inside the Venus crust, which would create earthquakes. So these things have both been proposed and are part of a NASA concept study that's under review at the present moment.
Well, Dr.
If I could ask, can I ask one last question really quick? Because this is something I've been thinking about the last couple of days, because I'm an impact specialist. So I'm wondering, we don't see a lot of evidence of craters on Venus. Is that because of the maybe tectonics and volcanism and things eroding them away? Or is it because of the really thick atmosphere, it's a lot harder to get a large impactor through that atmosphere? Or is it maybe a little both, I'm guessing?
The answer is number two. It's because objects have to be really big to crunch through the Venus atmosphere, which is so thick. And we see very little evidence of the craters being modified or destroyed by tectonics, which of course is consistent with the fact that they're continually being created, and every 500 million years or so, there's an immense catastrophe which wipes them all out. And then the rest just fall on the surface and are maintained until we view them with radar looking through the clouds.
What would cause these impulses of activity every 500 million years? Do we know any bodies that have this sort of behavior?
No. Venus would be the best example. And I did a demo for YouTube where I put some chocolate pudding in a little tray and I ran a burner underneath it, representing heat from the interior of Venus, heating the surface, which is actually rock, but I simulated with pudding. And so you can imagine that as the pudding starts to bubble, it becomes much more fluid, and you could heat up spots underneath the chocolate pudding, which would then spread out to melt the whole surface and destroy any structures you had before. I have to say the demo didn't work, and that also is the case with Venus. If you have hot spots, they tend to make local areas of melting and exchange, like the Hawaiian Islands on the Earth. And I was not able, in my simulation with chocolate pudding, to simulate the complete overturn of the Venus surface, but it would be the best ever disaster movie if it really occurred.
And with that, Dr. Larry Esposito, thank you so much for joining us today. It was a pleasure talking with you.
You're welcome. My pleasure.
And that wraps things up for today's episode. We'd like to thank Dr. Larry Esposito for giving us his time this morning to talk with us about Venus and everything surrounding this new discovery of phosphine. That was a lot of fun. And next week, we're going to be talking about craters with Dr. Kelsey Singer. So if you've ever looked up at the moon, maybe during a full moon, you notice all sorts of cool stuff on the surface. We're going to be talking a lot about the science behind those things, which are craters. So that'll be a lot of fun. You can always check out our upcoming episode schedule or send us your questions or do really any number of things from our website, colorado.edu/Fiske. Check it out. There's a lot of cool stuff to look at there. And one of those things is, if you feel so inclined, you can help support A View from Earth. This is a tough time right now, I think, for everyone, right? Financially speaking, including the podcast. And we'd like to give you the opportunity to give us the opportunity to give you more content. And so any donations are greatly appreciated, and we thank you. Also, to make sure you don't miss other episodes in the future, in case you haven't already, subscribe so that you get a notification every Thursday when a new episode comes out, and that way you can go ahead and give it a listen. This podcast is on YouTube, SoundCloud, Apple Podcasts, and Spotify. And from all of us here at A View from Earth, thank you for listening. We'll catch you next week.